Hello, so continuing on problems from biweekly contest 101. The third problem is make K-Subarray sums equal. So what this problem says is basically we get an array and an integer k, and this array is circular. Basically it means that the next element for the last one is the first one, and the previous element for the first one is the last one, right? And we are allowed to do this operation any number of times, and that operation is increasing or decreasing by 1. Okay, and what we want to do is return the minimum number of operations such that each subarray of this length k is equal. The sum of each, not the subarray equal, but the sum of each subarray of that length k is equal. That's what we want to do. The minimum number of operations such that the sum of each subarray of length k is equal. Okay, so let's take a look at an example here. So the first example, k equal to 2. So we want to make each subarray of length 2 have the same sum. So what are the subarrays of length 2? Well, just this one, and then 4, 1, and then 1, 3. Those are the only subarrays of length 2. So what we can do is just decrement the 4 by 1, so we get 3, and then that way we'll have equal subarray sums, because 1, 3 is going to have sum 4, 3, 1 is going to have sum 4, and then 1, 3 is going to have sum 4, right? So that's the idea here. We have actually 3, 1, and then 1, 3. Yeah, sorry, it's circular. So also 3, 1 here has sum 4. Here I forgot to mention this 3, 1 here is also a subarray of length 2. So that's how many operations we just needed to decrement this 4. So that's just one operation. Okay, so that's the idea. Now how do we tackle it? Okay, so how do we tackle this problem? Let's first start out with a couple of observations. So the first example is like this, and k equal to 2. And what the example says is we are going to reduce it to something like this, right? And one thing you notice when you look at this is that it seems like there is some sort of cycle or a pattern, right? We have 1, 3, 1, 3, and then 3, 1, right? And it stops here because it's circular, right? So you can see from this that 1, 3, 3, 1. Sorry, I forgot this one. 3, 1, 3, 3, 1, 1, 3, 3, 1, right? So we get 1, 3, 3, 1, and then we get 1, 3, 3, 1 2 times, right? So this may make you think, okay, seems like there is some repetition going on here. So let's try to explore this a little bit. So if you take a look at just what the problem says is that each subarray, right, of length k, right, needs to have a sum. The sums need to be equal, right? So what does that mean? So let's say this is a, right? So what this means is basically a of 0 plus a of 1 all the way to a of k. Let's actually just do it with, yeah, a of 1, assuming here k is bigger or equal to 2, right? All the way plus a of k minus 1. This is the first subarray, right? So the first subarray, the second subarray starts from a1 all the way to k, right? And since the sum of all of the subarrays are equal, that means this needs to be equal to a of 1, the second subarray, plus, basically we just shift by 1, plus a2, plus all the way to ak, right? Now if we look at this a little bit here, what you notice is that this here, actually let's break this down even more. So this would be plus all the way to, let me actually just use the same pen here. So it would be plus all the way to plus ak minus 1, and then plus ak, right? And so what you notice here is that this first portion is actually equal to this portion all the way, right? And so with equality, that means we can just sort of remove this, and what we are left with is that a of 0 needs to be equal to a of k. And if you sort of try this also for a of 1, for the next part, which is a of 1 plus a of 2, all the way to ak minus 1, ak is going to be equal to also the next one all the way up to 2k, right? And from that one, you will also find a similar thing where a of k is equal to a of k 2 multiplied by k, right? And if we generalize this a little bit for all of I values, right, then we can say that a of I is equal to a of I plus k, right? And then a of I plus k also is equal to a of I plus 2k, right? And this is sort of makes sense, right? Because let's take a look at, for example, something like 1, 4, maybe 3, 2, 1, I don't know, maybe 3, an array like this, right? And let's say k is equal to 3, right? So in the first one, 1 plus 4 plus 3 needs to be equal to the second part, which is 4 plus 3 plus 1, which needs to be equal to the third one, which is 3 plus 4, 3 plus 2 plus 1, which needs to be equal to, let's actually move this a little bit, which is 3, so this is plus 2 plus 1, which needs to be equal to 2 plus 1 plus 3. You get the idea here, right? And so if you look at this actually, well, this part is already there, right? And so for these two to have the same sum, we need this one and this one to be made equal. So we need to apply an operation to make this one and this one equal. We have two choices. Either we can decrease 2 by 1 or increase 1 by 1 here. Whichever we do, but we have to do it to make them equal, right? So that's the first, the same observation as in the what I explained above. Okay, and then if you look at it, if we continue to look at this down, then for the second array here, what is happening is that this 3 plus 2 is already equal. And so what we need to do is make this 1 and this 4 equal, for the subarrays to be equal. And similarly, 2, 1 here, right? And then these are already equal, so we should be good. We don't need to change anything in that last example, right? So you can see here, basically what this is saying is that for all of those that are sort of here and here at the boundaries where the subarrays don't intersect, the values need to be equal. Okay, so now the question is, how do we put these in a same group, because we need them all to be equal, right? So how do we put these in the same group? Well, let's take a look at the index here. So this is 0, 1, 2, 3, 4, 5. So what's the index here? And if we look also at the first example that we have here, 0, 1, 2, 3. So what are the indexes that need to be equal? This one and this one. Okay? And this is basically, if you look at k equal to 2, it's the boundaries of k. And we have n elements, right? And we have k arrays. So what we need to find is just the GCD of n and k, right? Those are the groups that we will have. Those are the number of things we can break n into, right? And so what we can do is just have a map, right? So we can just have a map for these values. So let's take this example here. And let's create a map with these GCD values. And so we'll just go for I in the range of GCD of, here n is 6 and k is 3, right? So that's just 3, right? And so that means we need to have groups for 0, 1, and 2, right? So this would be our map here. And these groups are the values that we need to make equal. So let's look at our array. And so what's the first one? So the first one is index 0. So let's just put the value 1. Now, what's the next value? It should be this 2 here, right? So it's just the same thing we did here, where you see each time we add sort of the GCD here. So this is going to be going from 0 all the way to 3, right? Which is just basically what we are going to do is we can for each value that we add here is just a range, right? Starting from I, the first index, all the way to n, and the step is going to be the GCD, so that we can get actually these boundary values. So that's going to be first 1, and then the second one is going to be 2. So it's plus GCD, which is 3, so 0 plus that one is 3, and then 3 plus 3 is 6. So we stop, right? Because it's bigger than the length. And then we look at the second one, which starts out from 1, so we need to add the one at index 1, which is 4. And then 1 plus 3, that's 4, index 4, which is already 1, which is 1 actually here. And so we put 1. And then this next one is 4 plus 3, which is 7. Well, that's above the length, so we stop. And now we look at 2. Well, 2 is 3. And once the next one, 3 plus 3 is 6. That's beyond the length, and so we stop. So these are the groups we have. And so what we are looking for is to use the minimum number of operations to make these equal, right? And so how do we accomplish that? Well, for that technique, here we have just 2 elements, so it's easy to do manually. But if we had 5 or 6 elements, the easiest way to do it, which is what we want to do, is basically just take an array, and in minimum number of operations, make all elements equal. So how do we do that? So let's say you have 1, 4, 2, 3, 1, something like this. How do you make all the elements equal? Well, the known way to do it is just to take the median of the array and convert all the elements to the median. Now, why the median? Well, the idea is that the median divides the array into equal parts on the left and the right, right? And so since we do +1 and -1, we will do equal portions of +1 and -1 on the left side and the right side, because the median, that's the definition, it divides the array in half. And so it's the most optimal. You could also just do a proof by contradiction, but I will leave it out here. But whenever you want to use some sort of minimum operations with an array to make the values equal, then yeah, think about the median. And so that's what we will do here. And so what's the median in this case? So we'll need to sort first to get the median. So 1, 1, 2, 3, 4. So here the array size is odd, so it's easy, so it's just 2. Now if the array size was even, let's say 2, 3, 4, something like this, what do we choose? And the answer is that it doesn't matter. You could choose either 2 or 3. Some other cases they use 2 plus 3 divided by 2. But in our case it doesn't matter here. Why? Because if you choose 2, then you will end up needing to subtract this 1 by 1 to make it equal. If you choose 3, you will end up adding 1 here to make it equal. So if you choose one and not the other, you will end up making up for the difference by needing to make that left one equal to the median. And similarly, if you choose the left one, right? So that's sort of the idea. So it doesn't matter which one you choose. So in our case here, we'll always then just choose the element in the length of the array divided by 2 as the index to get the median. Okay, and so once you have the median, it's easy to know how many operations you need to get all of them to be equal to the median. Well, how do you calculate that? Well, here the median is 2, so how many operations does it take to make one equal to it? Well, it's just the absolute difference between the median and the elements, right? So here it's 1, here it's 1, here it's the same, so it's the median itself. 3, so it's going to be 0 here, right? For 3 to get it to median, which is 2, it's 1. For this one it's 2, so the overall is just the sum of these, which is 3, 5, right? So that's the idea. So let's sort of summarize again what we are going to do. We are going to create a collection, a map, right, where the keys are sort of the groups that with the elements that need to be equal, so that we can have these boundaries equal, because the rest sort of cancels out to get the sum to be equal. And so we'll have the groups defined by these values, and then for each one of them we will make all the values equal using the median here. And once we do that, once we make them all equal, and for example this one will be equal, A0 will be equal to AK, and then AK will be equal to A2K, and then we'll do it for all the indices I, then we'll guarantee that the sums are equal, right? So that's the idea here. I hope that was clear. Now let's just implement it and make sure it passes. Okay, so let's implement the solution that we just saw in the overview. So what we need is just first, let's just get the length of the array. And then we need to get the GCD, which is going to be like this. And then we need to get the values, right? And so we can just have our collections that we mentioned, which is going to be just a collection of, we will default to empty list. And then we'll go for I in the range of that GCD. And then for each values for that I, we are going to append the element at I for, this is actually maybe better to do like plus, right? Because this is going to be a list in the range of starting from I, but we'll go by GCD, right? Because remember, if we do for I, we need it to be equal to I plus K, and then to I plus 2K, all the way to the end. Okay, so that's this here. And so once we do that, then we have the values. Now we need to make them equal and calculate the total cost of doing that. And so to do that, well, we can just go through the values for lists in values. So first we need to sort, right? So that we can get the median. So the median is going to be, let's call it, let's just keep it list. So it's going to be the length of the list divided by 2. That's what we said. This will work for both even and odd length lists. And so this would be the median. Now to make all the values in the list equal to the median is just going to be the sum of the difference of the median minus the elements. Let's call it A, and A is just the elements of the list. And we'll add this to our total cost. Okay, and we can return the cost. Okay, so it looks like this values for this. Yeah, maybe we can actually just do it like this. So we'll do it like this, and then values, and then just append A of I like that. So this is actually array, and let's just, to prevent collision here of these two variables, let's just make this J. And then this is actually, let's call this maybe collection or something, or dict. Just D to make this. And then we want to get the values, right? Because we only want to get the list. And that should be it. That should work. So let's run it. Looks good. Let's submit. And that passes our test cases. Now, one thing you notice is that we actually don't need this D thing here. We can just do it in line. And so to do that, we can just get this here, right? And then for this, to construct the list here, what we can do is just say it's A of J for J in this. So this will give us the list, and we need it sorted. And this will be the list we need. And we can remove this. Looks like we also need to get rid of this because we no longer need it. And this is sorted list. For the array, this is array actually, that's what we need here. And that should be it. So let's run. Looks good. Let's submit. And this passes our test cases, right? Yeah, so the main idea here is to find the pattern, and then and the median idea as well. Yes, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.